So let's try to solve some more examples regarding Zener diode circuits or the Zener diode as a voltage regulator. So in this case, we have two conditions. First is when our load is 180 ohms, and second is when our load is 470 ohms. So determine VL, IL, IZ, IR for RL is equal to 180. Repeat if RL is equal to 470. Determine the value of RL that will establish maximum power condition for the Zener diode. And determine the minimum value of RL to ensure that the Zener diode is in the on state. Okay, so kaya na siya. Sige, so sort of a review from 5 minutes ago. Wala na siya nga step atong timan-an. Aside sa mga circuit techniques that we've learned before, Ohm's law, KVL, KCL, for the Zener diode, walang ni siya. First, solve the circuit load voltage as if the Zener diode does not yet exist. And if VL is indeed less than VZ, then the Zener diode does not exist, actually. So IL is equal to IZ is equal to 0, so IZ is equal to 0, case A. But if we could compute for the load voltage to be greater than VZ, then in effect, the new voltage will be, or will now be VZ. So I think appropriately formulate to siya nga problem kani to exemplify those cases. So let's start with 1, where RL is 180 degrees. And 80 degrees, sorry, 180 ohms. So we have a source of 20 volts DC. Volts DC source. IR is the current across the source resistor, 220 ohms. IL is the load current across the load, of course, and IZ is the Zener diode current. So let's try to solve for voltage divider, voltage drop across the load, as if wala sa Zener diode. Okay, so that would be VL equal to PS R2 over R1 plus R2. VL is equal to 20 times given 180. 180 over 180 plus 220. How much is VL? Kasi makasolve. Kasi may calculator. Pwede.
Nine, sir.
9. Okay, very good. 9 volts. Thank you. Conclusion. Conclude na tadlit siya. Because VL is less than VZ, okay, case A, VL is less than VZ, IZ is equal to 0. IZ equal to 0 amperes. Pumanggi pong tana. IZ, IL and IR in this case will be equal. Solve na natin yung uban, no? Solve naman natin yung CVL. Solve na siya. IZ is 0. So let's solve for IL and IR, which will be equal. In effect. So itong circuit is as if, ngani na lang, no? 20 volts. Si Zener diode. So 220 ohms. 80 ohms. Therefore, I is equal to 20 over I over V over R. So 20 over 220 plus 180. Circuit current is 50 milliamperes. Therefore, IL is equal to IR equal to 50 milliamperes. Final answers. About ana, no? About case B. Where load is 470 ohms. So ito lang repeat itong analysis. V2 or VL is equal to 20 volts, 70 over 220, 470. Yan. 13.62 volts, which is case B, where because VL is greater than VZ, okay, or 13.62 is greater than 10 volts. Therefore, new VL is equal to 10 volts. So itong yung VL. Automatic. Okay. So kaning 13.62 is temporary voltage so na just to see if na forward bias na reverse bias ba ang atong Zener diode. So medyo awkward sa paminaw, no? Gusto ta nga i-reverse bias ang atong Zener diode. So tuon na reverse bias gid siya, having a voltage now of 10 volts. So the voltage, the Zener diode has regulated, so to speak, the voltage across the load. Instead of it being 13.62, it's now only 10 volts. So if it's 10 volts here, how much will be load? Load current. Load current would be solved the same way. IL is equal to I equals to V over R. IL equals to V L over RL. 10 over 470 21.28 milliamperes. Next, would like to guess how much is the voltage across the 220 ohms resistor? Kasi makatagna. Remember, atong source is 20 volts. Giregulate ni Zener diode ang atong load to 10 volts. How much now is the voltage across the source resistor?
10 yapon, sir.
And very good. So it's also 10 volts. So, kung gusto formal na solution, that's 20 minus VRS minus VL, which is 10. So 10 volts gihapon. So there, kung formal gyud, VS minus VRS minus VL equal to 0. So 20 minus VRS minus 10 to 0. Therefore, VRS is equal to 10 volts. We could now solve for IRS. IRS is equal to VRS over RS 10 over 220, which is equal to 45.45 milliamperes. PL na siya. Now we have the currents, IRS and IRL. So mag-KCL ta dire, no? KCL ta right there. In that node. Perform the KCL dito. IRS. KCL ta naman mga current. This one, that one, and that one. IRS, IZ, o IL. So IRS or IR yung gigamit daan nga notation. So ito na yung sundon. So IR is equal to IL plus IZ. .45 equal to 21.28 plus IZ. Therefore, IZ is equal to 24.18.
Hindi.
24.17
Hindi.
milliamperes. Okay, mga na siya. Pangitaon, VL-IL-IR-IZ. VL-IL-IR-IZ. Okay. Before we proceed to these questions, C and D, nasa tayo kanang buhaton nga check, no? Let's try to check if the Zener diode will not get busted. Okay? Kaya wala man takabalo. Although ni reverse bias siya. But let's say if let's compute if layo pa ba ni sa maximum, no? So how will we do that? Let's multiply VZ and IZ to get PZ. PZ is VZ times IZ. VZ is 10, IZ is 24.17 milliamperes. Therefore, PZ is 241.7 or 242 milliwatts, which is less than PZ max. How much is PZ max? It's given as 400 milliwatts. So that's the maximum power that our Zener diode could withstand. So for this particular circuit, layo pa. No? Ang atong load nga 470 ohms is layo pa sa iyahang maximum. No? Because our PZ max is 400 milliwatt. It's still far less than PZ max. Okay, so this is good, meaning our Zener diode will not only will work, but will not get busted. So that's for B. How about for C? Determine the value of RL that will establish maximum power conditions for Zener diode. So C. Okay. So let's try to think of it like this. Let's say line is the axis for RL. So this line is the axis for RL. So sa itong mga given, 470 and 220, we have determined, not 220, 180. So we've determined that 180 is not enough. We've also determined that 470 is enough. So ang question, sa actual nga range of values mo na siya ang kaning mga questions actually. No? Determine the maximum, the value of RL, or perhaps the maximum value of RL that will establish maximum power conditions for Zener diode, and the minimum value of RL to ensure that the Zener diode is beyond state. So my question is, what are those minimum and maximum values? Maybe one is sila, no? So natay RL min actually and RL max. Itong atong mga given earlier, maybe they fall in these lines. Si 180 ohms na dire. Si 470 ohms na siya dire somewhere in between. So itong pangitaon si RL min o RL max. Muna siya ang point ani nga mga two questions. Kasi pinakauna nga sa'yo magkuha. Sa'yo na siya si max, si min. Yeah, I think masayon ko on si min. Si minimum value. So this is supposed to be D. Return lang na si C. Okay. D. So to get the minimum value for RL, we'll still use our voltage divider formula. Vs R2 over R1 plus R2. With R2 being unknown. And if we assume that it is already established na naon atong zener diode, meaning VL would now be equal to 10 volts. 10 is equal to 20 times R2, which is RL, over 220 plus R2. Therefore, R2 is equal to, so you could use algebra to extract the value for this one, or you could use your calculator, shift solve lang. Maput akong buhaton. So 10 is equal to 20x over 220 plus x. Shift solve. R2 is equal to 220. So the answer 220 ohms. Okay, seems logical because ang VZ is half man sa VS. So sakto dahil ni 220 gid ni siya. 220 ohms, which is more than 180 but less than 470. So 220 ang minimum value of RL for the zener diode to be turned on. So yun day, masolve ang D. Let's solve for C. The maximum value. Where will we know what is the maximum value of RL? Kasi sa kato atong gibuhat kanina, no? We'll utilize PZ max. Diyan nato makuha ang maximum value for RL actually. PZ max is 400 milliwatts. So if that is the maximum power that the zener diode could withstand, max slack na to ang IZ max. So first na to makuha sa pag-obtain sa maximum power is ang maximum IZ. So PZ max is equal to power is equal to current times voltage, diba? VZ times IZ max. VZ max is given 400 milliwatts equal to VZ is 10. IZ max dividing 10 both sides. IZ max is equal to 40 milliamperes. Balik sa atong KCL equation, in utilizing this one, IR is equal to IZ plus IL. So si IZ dire is maximum value, which is this one, 40 milliamperes. IL actually is fixed, diba? Because once the Zener diode will conduct, the 10 volts across it will remain constant. So IL is always fixed now once the Zener diode is turned on. Yeah, mabon yung route gamiton. Yeah, sakto. No. Yeah, although fixed siya. Yeah, fixed noon siya. But sorry, ang fixed sa dili ang voltage across it or ang current dili fixed. Variable. So scratch that. Ang IR di ay ang fixed. So once mag-conduct ang load, ang voltage across the source resistor is the one that will be fixed di ay. So one incorrect na pa. So how fixed is it? We'll use this one, 45.45. Na-obtain na natin na ganina. So 45.45 milli is equal to 40 milli for IZ, which is this one, plus IL. So minus ang nato, meaning the maximum load current should be equal to 5.45. 5.45 milliamperes. So if muna siya ang load current, so na tong value sa resistor sa kana nga kuan, current value, Ohm's law, R L max is equal to V over I, VL over IL. VL is fixed. Voltage dahil sa load ang fixed. Di ang current. 5.45 milli. Therefore, maximum RL is equal to 1833.33 ohms. Final answer. And to check if this is really the answer, we could solve for PZ. Pero I'm sure ang makuha na to nga PZ ani is 400 milliwatts. Ito na ako side note din. At this value of RL, PZ is 400 milliwatts. So na-reach tong maximum, which is this one, given. Sumunod ni atong kuan di ay, line. So the maximum value for RL, so that the Zener diode will not go busted, is 1833 ohms. Okay. So more na siya. That's it. Guys, any questions?